Students, today's topic is about the derivatives of logarithmic functions. So there are three kinds of logarithm. The first one is natural logarithm. So first of all, we need to discuss the natural logarithm and its derivative. The log having base e, where e is an irrational number between 2 and 3. So the log which has base e is called natural logarithm, denoted by ln. That is, we can write log having base e. This is actually natural log. So natural log is denoted by ln, and here is x. So that kind of log is called the natural log of x, denoted by ln. And we know that from your second year mathematics course that the derivative of natural log of x is 1 by x. If there is only x, so follow this formula, and if there is u instead of x, where u is the function of x, there are extra numbers, extra powers with x. So whenever there is log of u, so that is the same 1 by u as 1 by x. So that is 1 by u into further derivative of this u. So these two are the formulas for the natural derivatives of the natural log of a function. For example, we need to find the derivative of natural log of x squared plus 1. So we see that this is the function of x, not only x but the function of x. So applying this formula, that is 1 by u. Instead of u, there is x squared plus 1. So the derivative of log of x squared plus 1 is 1 by x squared plus 1, just like 1 by u. So that will become 1 by x squared plus 1 into further derivative of this x squared plus 1, and further derivative of x squared plus 1 is 2x. Applying this ddx within these brackets, this is some rule. So derivative of x squared is 2x, and derivative of 1 is 0. So that is 2x, and 2x into 1 is 2x divided by x squared plus 1. So that's how we use the formula for derivatives for the natural log of a function. Secondly, we have got general logarithm. So logarithm whose base is other than e is called general logarithm. So that is written in front of you, that log having base greater than 0 other than e, this e is called general logarithm. That is log to the base a, log to the base a. Now this a is not e, that is other than e, and this a, this base, is greater than 0, that is greater than 0. This is very important. So log to the base a, x, is actually general logarithm. What is the derivative of a function having general logarithm? That is in front of you. Derivative of log to the base a x is the same 1 by x, just like that, the same 1 by x, the same 1 by x, but there is another quantity which is multiplied with x, is natural log of this base, natural log of a. So 1 by x into natural log of a is the derivative of this general logarithmic function. If there is a function instead of x, I mean the function of, if the function of x is there, then that is the same 1 by u into natural log of a, but further derivative of this u, just like this formula. So that is the main difference between these two formulas. So remember that in natural logarithm there is no There is actually a natural log of e, because the base of natural log is e. So there is natural log of e, but natural log of e is equal to 1, so that's why we do not write this thing. For example, if you need to find the derivative of log to the base b x square plus 1, the same function is taken, x square plus 1, but the base has been changed. For natural log of x, the base is e, and that is written in ln form. But for general logarithm, we cannot write this log as ln, so that is log to the base b x square plus 1. Now this is general logarithm, and the derivative of the general logarithm of a function is 1 by that function into natural log of the base, natural log of the base b, that is the natural log of the base b, into further derivative of this u, x square plus 1, that is u, and derivative of x square plus 1 is 2x, so that is 2x divided by this whole function. So this is the main difference between the derivative of natural log of a function and the derivative of a general log of a function. Let us apply these formulas on the questions. So concentrate questions on derivative 6. Questions on derivative 6 will be sent to you. Maybe that has been sent to you people in the group. So question number 1 through 26. From question number 1 through 26, we need to find dy dx, the derivative of y with respect to x. Question number 1 is y is equal to natural log of 5x. So you see that is natural log of u. We need to find the derivative of this function with respect to x, so differentiate with respect to x. So applying d dx on both sides, dy dx is equal to derivative of log of 5x. Now derivative of log of 5x is 1 by 5x into further derivative of this 5x, and further derivative of this 5x is 5 into 1, so that is 5 into 1. 5 into 1 is 5. Now 5 cancel, so that is 1 by x. So that is the derivative of this function. Question number 2, we need to find the derivative of this function, that is again a natural logarithm. So differentiate with respect to x, applying d dx on both sides, d dx on this side as well as on that side. So that is derivative of natural log of u, that is u. Derivative of natural log of u is 1 by u, 1 by that u, into derivative of this x by 3 again, and derivative of x by 3 is derivative of x is 1, so that is 1 by 3, 1 by 3. Cancelling this 3, we get 1 by x. That is the derivative of this function. Question number 3 through 6, those are same questions. Among those questions 3 to 6, we are going to solve question number 4. We need to find the derivative of this function, y is equal to natural log of 2 plus square root of x. So differentiate this function with respect to x, applying d dx on both sides, so that will become dy dx, and this is d dx of natural log of 2 plus square root of x. Now applying the formula, derivative of natural log of u, natural log of u is 1 by this u into further derivative of this u. We can write square root of x in this fashion. Now this is sum rule, applying d dx on 2, that will become 0, and applying this on this function, so that is power rule. So by power rule, that is power down and 1 less than power, x to the power 1 by 2 minus 1. Taking LCM of 1 by 2 minus 1, we will get minus 1 by 2, so that is minus 1 by 2. because the power of x is negative here, so we need to shift this x in the denominator. That will become positive. That will become x power 1 by 2 here, and x power 1 by 2 is square root of x. So we write this function in this fashion, that 1 by 2 is written in the front, and square root of x, this square root of x is written this here, and that function is written there. So that is the derivative of this function, natural log of 2 plus square root of x. You can solve questions 3 up to 6 in the same manner. Now in this slide we just want to study the laws of logarithm. The first one is natural log of m into n is log of m plus log of n. If there is multiplication between two functions and you apply the log on that function, log of the multiplication of two functions is log of first function plus log of second function. If there is quotient of two functions, so put a negative sign there and write log separately on both the functions, with both the functions. And the third one is log of m to the power n. So log of m to the power n, the property of log is it drops down this power n here, so that will become n log of m. We have studied these three rules in metric course as well as in first year course. So remember these three laws for logarithm. We will apply those laws of logarithm to simplify the function and then find the derivative of the function. Question number 7 and 8 are same. Question number 7 says that find the derivative of this function, log of x divided by 1 plus x square. So first of all, you can apply the derivative on this function directly, but that will become quotient rule, which takes time to solve the question. So first of all, we need to simplify this function by using the laws of logarithm. So we know that log of m by n, applying this rule, log of m by n is log of m minus log of n. So we have simplified this function using rules of logarithm. Now y is this function. Differentiate this function with respect to x on both sides, differentiating y and differentiating this function with respect to x. Now this is a difference rule. Apply this ddx inside with both the functions, and now this is derivative of log of x, and that is derivative of log of u. So applying the formulas, derivative of log of x is 1 by x, and derivative of log of 1 plus x square, that is 1 by 1 plus x square, into further derivative of 1 plus x square. And further derivative of 1 plus x square is 2x. Now writing 2 here, 2x into 1 is 2x divided by 1 plus x square. So this is the derivative of this function. So you see that we have solved this question in 4 steps. If you directly find the derivative of this function, so it will involve the derivative of the quotient of two functions, and that will become too lengthy to solve. So see whether the function can be simplified using the laws of logarithm. If that is possible, then first simplify the function and then differentiate it with respect to the variable involved. In this slide, question number 10 and 11 are same. Question number 11 says that find the derivative of y is equal to square root of log of x. So square root of log of x can be written as log of x whole 1 by 2. So differentiating this function with respect to x, dy dx is equal to dy dx of this function. Now see that this is actually extended power rule, because this is not x only, that is actually log of x. So applying the extended power rule here, dropping down this power in front of the function and subtracting 1 from the power, and to further derivative of this base log of x. Now 1 by 2 minus 1 is minus 1 by 2, and derivative of log of x is 1 by x. Now you see that the power of log of x is minus 1 by 2, so in order to make it positive, shift it in the denominator. That will become log of x whole 1 by 2, and log of x whole 1 by 2 can be written in this version, square root of log of x, and there are 2 and x as well. So 2x into square root of log of x is the derivative of this function. You can deal with question number 10 in this by using this idea. Question number 9 and 12 are same. Question number 9 says that find the derivative of log of x square. Remember that there is a difference between log of x whole 1 by 2 and log of x power 1 by 2. This power is on this whole function log of x, that cannot be dropped down by the laws of logarithm, because log is itself under this power. Now in this case you see that log is free from this power. You can apply the rule of logarithm to drop the power in front of log, and that is log of x. So that will become 2 log of x. Now differentiating this function with respect to x, we will get dy dx is equal to d dx of 2 times natural log of x. 2 is constant, so writing here outside this derivative just like this thing, and that will become derivative of log of x, and derivative of log of x is 1 by x. So that will become 2 into 1 is 2 divided by x is the derivative of this function. Similarly 13 and 14 are same. Question number 13 says that differentiate this function y is equal to x into log of x. We see that this is the product of two functions, the product of x and log of x. So we will apply here the product rule. Differentiate with respect to x this function and differentiate this as well. So that is product rule u dot v. Applying the product rule here, that is first function derivative of second function plus vice versa, second function derivative of first function. Now derivative of log of x is 1 by x and derivative of x is 1. So that cancelling this x from here, so that will become 1 plus log of x. So that is 1 plus log of x is the derivative of this function x into log of x. In this slide, question number 19 through 24 are same. Question number among these questions 19 through 24, we are going to solve question number 20. Question number 20 says that find the derivative of y is equal to log of x. So there are 3 logs. Differentiating this function with respect to x, whenever you differentiate this function, dy dx is equal to d dx of log of this whole function. So log of u, this whole is u, log of u will be equal to 1 by u, 1 by this u into further derivative of this u. Now again, this is the derivative of log of u. Now u in this case is log of x. Derivative of log of u is 1 by u. U is log of x. 1 by u further derivative of this u, log of x. And now derivative of log of x is 1 by x. So that is 1 into 1 into 1 is 1, and then writing x first, then log of x, then log of x is the derivative of this function. So I hope this question is simple to solve. You just need to recognize u in this function. Now question number 17 and 18 are same. Question number 17 and 18, simple log is used. So whenever there is simple log, it means that the base of this log is 10, and whenever the base of a log is 10, that is called common logarithm having base 10. So the log having base 10 is called common logarithm, and that is a category of general logarithm. Question number 17, you need to find the derivative of this function. Y is equal to x squared by 1 plus log of x. You see that this is simple log, there is no base mentioned here. So if there is no base mentioned here, it means that the base of this log is 10. So differentiating this function with respect to x, whenever you differentiate this function with respect to x, so that is quotient rule. Quotient rule. Applying quotient rule, 1 by denominator square into denominator into derivative of numerator minus vice versa, I mean x square into derivative of this function. Now I write here log to the base 10 instead of log of x in order to find the derivative of this function. Now in this step, find the derivative of x square, which is 2x, and apply this ddx inside. Derivative of 1 is 0, and derivative of log to the base 10x is 1 by x into natural log of the base 10. Natural log of the base 10, that is the derivative of general logarithm. As we know that derivative of log to the base ax is equal to 1 by x into natural log of the base a, that is actually a. So in this question a is 10, so that is natural log of 10. Simplifying this function, writing 2x in front of the function, and that is cancelling 1x from here, x with this x square, so that will become negative sign. 1x is remaining here, so x into 1 is x divided by log of 10. Now this is the answer. You can simplify this answer as well by taking x common from these two. So x is common from these two, and this is the complete answer of this question. So I hope quotient rule is a bit simple to understand, and product rule as well. And in this slide, question number 27 through 30 are same questions, and in these questions, question number 27, 28, 29 and 30, we need to use the method of example 3 to help perform the indicated differentiation. What is the method performed in example 3? In example 3, we need to apply the laws of logarithm first to simplify the given function. So first of all, use the laws of logarithm and then differentiate the given function. So that is the workout in example 3. Question number 27 says that find the derivative of this whole function. So we see that this is the derivative of log of m into n. So first of all, simplify this function with the help of rules of logarithm. Log of m into n is log of m plus log of n. Now we can apply the third rule, that log of m power n, dropping this power in front of the log here. By using this law, we have simplified the function in this law, and dropping this power in front of the log and dropping this power in front of the log. So that is the simplest form of this function by using the rules of logarithm. Now differentiate this function, apply this ddx inside. This is actually sum rule. So whenever you apply this ddx inside, 3 is constant, So write it out from this derivative and write 4 out of this derivative. Now you see that this is derivative of log of u, and that is derivative of log of u as well. So apply the formula. Derivative of natural log of u is 1 by u into further derivative of this u, and here log of x square plus 1 is 1 by x square plus 1 into further derivative of x square plus 1. Now further derivative of x minus 1 is derivative of x is 1 and derivative of 1 is 0, so that is actually 1. You see, derivative of x is 1, derivative of 1 is 0, and here derivative of x square is 2x and derivative of 1 is 0. Now further multiply 3 with 1, so that is 3. Multiply 4 with 2, so that will become 4 2s are 8x divided by x square minus 1. So that is the whole story about the derivatives of functions having natural